In this video, we will discuss number 1, the concept of determinant, number 2, Cramer's rule to solve linear equations in 2 variables and 3 variables, and number 3, how to find area of a triangle using determinants. Hello friends, you are watching channel number collage. This channel features concept videos on mathematics which you would love to watch. Today we will understand the concept of determinants. Consider two linear equations in x and y. a1x plus b1y equals 0 and a2x plus b2y equals 0. The first equation can be written as b1y equals minus a1x, which further can be written as minus y by x equals a1 by b1. Let us name this equation 1. The second equation can be written as b2y equals minus a2x, which further can be written as minus y by x equals a2 by b2. Name this equation 2. Now since the left hand side is equal, we can equate the right hand side. So we write a1 upon b1 equals a2 upon b2, which we can write as a1 b2 equals a2 b1, which also can be written as a1 b2 minus a2 b1 equals 0. Now this form of equation can be written conveniently in the form of two rows a1 b1 a2 b2 and two columns between two vertical lines, which can be simplified as cross multiplication of a1 b2 minus cross multiplication of a2 b1 equals 0. So the method of writing a1 b2 minus a2 b1 equals 0 in the form of two rows a1 b1 a2 b2 or as two columns a1 a2 b1 b2 between two vertical lines is known as determinant, which can be evaluated by first taking a cross product of a1 b2 from which the cross product a2 b1 subtracted and equated to 0. Next, let us understand order of determinants. Determinant is denoted by capital D. So, the determinant A1 B1 A2 B2 has two rows and two columns. Therefore, this determinant has order 2 by 2 or just order 2. We also can have a determinant having three rows a1, B1, C1, A2, B2, C2, A3, B3, C3. Since this determinant has three rows and three columns, this determinant has order 3 by 3 or just 3. The order 2 by 2 or 3 by 3 is always an ordered pair where the first number indicates the number of rows and the second number indicates the number of columns present in that determinant. Now let us understand how to find minor of an element of a determinant. In a 2 by 2 determinant a1 b1 a2 b2, suppose we want to find the minor of element a1 which belongs to the first row and first column. So for that we have to hide the first row and the first column, and what remains is the element b2. So this element b2 is called minor of element a1. Similarly, in determinant a1 b1 a2 b2, we want to find the minor of element b2. We have to hide the row containing b2 and the column containing b2. What remains is the element a1, and this is the minor of element b2. This is how we can find the minor of any element in the determinant D containing elements A1 B1 and A2 B2. Now let us see how to find minor of elements of a 3 by 3 ordered determinant. Consider a 3 by 3 determinant D equals A1 B1 C1 A2 B2 C2 A3 B3 C3. Suppose we want to find the minor of element B1, then we have to hide the row containing B1 and the column containing B1. What remains is the determinant formed by the elements A2, C2, A3, C3, which we write as D B1 equals A2, C2, A3, C3 is known as minor of element B1. Similarly, for the determinant D A1 B1 C1 A2 B2 C2 A3 B3 C3, if we want to find the minor of element C2, then we have to hide the row containing C2 and the column containing C2. What remains is a 2 by 2 determinant. Let's call it as a 2 by 2 determinant D C2, which contain elements A1 B1 A3 and B3. So the determinant DC2, which is A1 B1 A3 B3, is the minor of this element C2. Let us evaluate the determinant 2 minus 4 0 3. First, we will take cross multiplication of 2 and 3. So 2 multiplied by 3 minus cross multiplication of minus 4 and 0. So minus 4 multiplied by 0, it will be 6 minus 0. So the value of this determinant will be 6. Next, we will evaluate a 2 by 2 determinant 2, 4, minus 5, minus 1. First we will take cross multiplication of 2 and minus 1. So it will be 2 multiplied by minus 1. Then minus cross multiplication of 4 and minus 5. So it will be 2 multiplied by minus 1 minus 2 minus minus it will be plus, and 4 fives are 20. So value of the determinant will be 18. Next, we will evaluate the determinant sec theta, tan theta, tan theta, sec theta. First, we will take cross multiplication of sec theta and sec theta, which will be sec square theta, minus we will take cross multiplication of tan theta and tan theta, which will be tan square theta. From the trigonometric identity, sec square theta equals 1 plus tan square theta. We get sec square theta minus tan square theta equals 1. So the value of this determinant will be 1. Now we will understand how to evaluate a 3 by 3 determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. First we will write the first element of the first row A1 multiplied by its minor, which is B2 C2 B3 C3. Then we put a minus sign and write the second element of the first row B1 multiplied by minor of the element B1, which is A2 C2 A3 C3. Then we put plus sign and write the third element of the first row C1 multiplied by minor of C1, which is A2 B2 A3 B3. That gives us A1 into bracket B2 C3 minus C2 B3 minus B1 into A2 C3 minus C2 A3 plus C1 into A2 B3 minus B2 A3. After evaluating this, we get the value of this determinant. Let us evaluate a 3 by 3 determinant 2 minus 1 minus 3 4 1 0 5 2 1 equals First, we write the first element of the first row, which is 2, multiplied by minor of the first element 2, which is 1, 0, 2, 1. Then we put the minus sign, and then the second element of the first row, which is minus 1, multiplied by minor of this second element minus 1, which is 4, 0, 5, 1. Then we put the plus sign and write the third element of the first row, which is minus 3, multiplied by its minor, which is 4, 1, 5, 2, which will be 2 multiplied by 1 minus 0 plus 1 multiplied by 4 minus 0 minus 3 multiplied by 4 2s are 8 minus 5. It will be 2 into 1, that is 2, plus 1 into 4, which is 4, minus 3 multiplied by 3. So that will be 2 plus 4 minus 9. That gives us 6 minus 9, that is minus 3. So the value of this determinant is minus 3. We have to find the value of x if determinant 2, 3, 4, 5 equals x, 3, 2x, 5. Determinant on the left hand side will be 2 multiplied by 5, 10, minus 3 multiplied by 4, 12, equals x multiplied by 5, 5x, minus 3 2s are 6x. So that will be minus x. So we get minus 2 equals minus x, that is x equals 2. So x equals 2 is the value of x. Next, we also have to find the value of x if determinant x2 18x equals determinant 6 18 6. Determinant on the left hand side will be x multiplied by x, that is x squared, minus 2 multiplied by 18 is 36, equals 6 multiplied by 6 is 36, and 2 multiplied by 18 is 36, cancels with 36, and we get x square equals 36. Taking square roots on both sides, we get x equals plus minus square root 36, which is plus minus 6. So these are the values of this x. Let us solve a determinant equation 0, 1, 0, 2x, 1, 3x equals 0 for x, which means we have to find the value of x. For evaluating the determinant, we write 0 multiplied by the minor of 0, which is 2x, 3x, minus this 1 multiplied by the minor of 1, which is x, x, 1, x, plus this 0 multiplied by the minor of this 0, which is x, 2, 1, 3, all equals this 0. Now 0 multiplied by this determinant will be 0 minus x squared minus x, plus 0 multiplied by the determinant will be 0 equals 0. That will be x squared minus x equals 0, or x multiplied by x minus 1 equals 0. So that gives us x equals 0 and x equals 1. So these are the two values of this x. We are going to see what is Cramer's rule and how it can be used to solve linear equations in two variables and three variables. To solve linear equations in two variables, we first write them one below the other, like a1x plus b1y equals c1, a2x plus b2y equals c2. Then we form a determinant made out of the coefficients of x, that is a1, a2, and coefficients of y, that is b1, b2. a1, b1, a2, b2, and we name this determinant d. Next, we will form another determinant by replacing the first column elements a1, a2 of d by the constants C1 and C2. So we write C1, C2 here and we name this determinant as dx. So we get another determinant dx equals C1b1, C2b2. Next, we form another determinant in which we replace this b1, b2 by C1, C2. So we write here C1, C2 and we name this determinant dy. So we get a determinant dy equals a1 c1 a2 c2. Now that we have three determinants d, dx and dy, according to Cramer's rule, we can write the value of x as dx by d and value of y equals dy by d. So this is how we can use Cramer's rule to solve linear equations in two variables x and y. We will solve a pair of linear equations in x and y by using Cramer's rule. 3x plus 4y equals minus 14 minus 2x minus 3y equals 11. First, we will form determinant D out of the coefficients of x and y. That will be 3, 4, minus 2, minus 3. Its value will be 3 into minus 3 minus 9 minus 4 into minus 2 minus 8. So that will be 8 minus 9 minus 1. The value of determinant D will be minus 1. Next, we will form a determinant dx by replacing the coefficients of x by the constant terms minus 14, 11 and writing the coefficients of y as they are 4 minus 3. This will be 14 threes are 42 minus 11 fours are 44. That will be minus 2. So the value of determinant dx will be minus 2. And finally, we will form a determinant dy by replacing the coefficients of y by the constant terms minus 14, 11 and writing the coefficients of x as they are 3 minus 2. It will be 11 threes are 33 minus 14 twos are 28. So that gives us dy equals 5. Now that we have the values of the determinants d, dx and dy, we can find the values of x. So the value of x will be dx by d, that will be minus 2 by minus 1, that is 2, and the value of y will be dy by d, that will be 5 by minus 1, that will be minus 5. So the solution of these linear equations in two variables are x equals 2 and y equals minus 5 by using Cramer's rule. Now we will see how to use Cramer's rule to solve linear equations in three variables x, y and z. First, we will write the equations one below the other. So a1x plus b1y plus c1z equals d1. a2x plus b2y plus c2z equals d2 and a3x plus b3y plus c3z equals d3. As usual, first we will form a determinant out of the coefficients of x a1, a2, a3, the coefficients of y b1, b2, b3, and the coefficients of z c1, c2, c3, and we name that determinant as d. D will be a1, b1, c1, a2, b2, c2, a3, b3, c3. Now we will replace a1, a2, a3 by the constant terms d1, d2, d3 and write d1, d2, d3 and we name this determinant dx. So we have dx equals d1, b1, c1, d2, b2, c2, d3, b3, c3. we form the next determinant dy by replacing b1, b2, b3 by d1, d2, d3. So we write d1, d2, d3. So we get determinant dy equals a1 d1 c1, a2 d2 c2, a3 d3 c3. And finally, we will form a determinant similar to this determinant d a1, a2, a3, b1, b2, b3 only by replacing this c1, c2, c3 by d1, d2, d3. And we name this determinant dz. Now that we have the determinants d, dx, dy and dz according to Cramer's rule, we write the value of x as dx by d, value of y as dy by d, and value of z as dz by d. So this is how we can solve linear equations in three variables x, y, z by using Cramer's rule. Let us see how to find area of triangle ABC, the coordinates of whose vertices are A 1 1, B minus 1 1, C 0 minus 2. Coordinates of A will be x1 y1, coordinates of B will be x2 y2, coordinates of C will be x3 y3. We have area of triangle ABC by determinant method as half multiplied by the determinant x1 y1 z1 x2 y2 z2 1 1 1, which will be half multiplied by the determinant 1 minus 1 0 1 1 minus 2 and 1 1 1. It will be half multiplied by the first element multiplied by its minor, which is 1 plus 2, then minus sign the second element 1 multiplied by its minor, which is minus 1 minus 0, plus the third element 1 multiplied by its minor 2 minus 0, which will be half multiplied by 3 plus 1 plus 2, which will be half multiplied by 6, that is 3. So area triangle A B C by determinant method will be 3 square units. We have to show that the points minus 1 minus 3 minus 4 7 and 2 minus 13 are collinear. Let the first point be x1 y1, second point x2 y2, and the third point be if the area of triangle formed by these 3 points as the vertices is equal to 0, then we can conclude that these 3 points are collinear. So let us first check area of triangle by determinant method. It will be half determinant x1, x2, x3, y1, y2, y3, 1, 1, 1, which will be half multiplied by minus 1, minus 4, 2, minus 3, 7, minus 13, 1, 1, 1. Let us evaluate. It will be half the first element minus 1 multiplied by its minor 7 plus 13, then minus sign, then second element minus 3 multiplied by its minor minus 4 minus 2, plus the third element 1 multiplied by its minor 52 minus 14. It will be half multiplied by minus 20 plus 3 multiplied by minus 6 plus 38, which will be half multiplied by minus 20 plus 20, which is 0. Since area of triangle equals 0, we can conclude that the points minus 1 minus 3 minus 4 7 and 2 minus 13 are collinear. Let us solve linear equations in three variables by using Cramer's rule. The first equation is x plus y equals 2. Second equation 3y minus z equals minus 4. Third equation is x plus z equals 3. First, let's write the determinant d, which will be the determinant of coefficients of x, y, and z. So we write coefficients of x 1, 0, 1, then coefficients of y 1, 3, 0, and then coefficients of z 0, minus 1, 1. We will evaluate it. The first element multiplied by minor of it, that will be 3 minus 0, then minus sign. Second element, then minor of it, 0 plus 1, then plus 0 multiplied by minor of it, which will be 0 minus 3. So it will be 3 minus 1 plus 0, that will be 2. So the value of d is 2. Next, determinant dx, which will be, replace the coefficients of x by the constant terms. So it will be 2 minus 4, 3. Then coefficients of y 1, 3, 0. Coefficients of z 0, minus 1, 1. It will be the first element 2 multiplied by its minor, which will be 3 minus 0, then minus sign. Second element multiplied by its minor, minus 4 plus 3, then plus 0 multiplied by its minor, 0 minus 9, which will be 6 plus 1 plus 0, that will be 7. So value of dx is 7. Then dy equals coefficients of x 1, 0, 1. Replace coefficients of y by the constant terms 2 minus 4, 3. Then coefficients of z 0 minus 1, 1. It will be the first element 1 multiplied by its minor, which will be minus 4 plus 3. Then minus sign. Second element 2 multiplied by its minor, which will be 0 plus 1. Then plus sign. Third element 0 multiplied by its minor, which will be 0 plus 4. So it will be 1 into minus 1, minus 1, then minus 2 plus 0, which will be minus 3. So the value of dy is minus 3. Finally, let us calculate dz. It will be first coefficients of x 1, 0, 1, coefficients of y 1, 3, 0. Then replace the coefficients of z by the constant numbers 2, minus 4, 3, which will be 1 multiplied by its minor, which will be 9, minus 0, then minus sign. Second element 1 multiplied by its minor, which will be 0 plus 4, then plus sign. Then the third element 2 multiplied by its minor, which is 0 minus 3. It will be 9 minus 4 minus 6, which will be 9 minus 10, which is minus 1. So the value of dz is minus 1. Now according to Cramer's rule, the value of x will be dx by d, which will be 7 by 2. So we get x equals 7 by 2. Next, y equals dy by d, which will be minus 3 by 2. So y will be minus 3 by 2, and z will be dz by d, which will be minus 1 by 2. So z will be minus 1 by 2. So x equals 7 by 2, y equals minus 3 by 2, and z equals minus 1 by 2 is the solution of these three linear equations in three variables x, y, and z. Let us solve a linear equations in three variables x, y, z by using Cramer's rule. The equations are x plus 2y plus 3z equals 17. 3x plus 2y plus z equals 11. X minus 5y plus z equals minus 5. First, let us write determinant D, which is the determinant of coefficients of x, y, and z. So it will be 1, 2, 3, 1, 2, 3, then 3, 2, 1, and 1 minus 5, 1. Let us solve it. First element in the first row, 1, multiplied by its minor, which is 2, 1, minus 5, 1. Then minus sign. Then second element from the first row, which is 2, multiplied by its minor, which will be 3, 1, 1, 1, plus the third element in the first row, 3, multiplied by its minor, which will be 3, 2, 1, minus 5. It will be 1 into 2 plus 5 minus 2 multiplied by 3 minus 1 plus 3 multiplied by minus 15 minus 2. It will be 7 minus 4 minus 51. It will be 7 minus 55, which will be minus 48. So the value of D is minus 48. We write the value of D equals minus 48. Then we will write determinant dx. First we will replace the coefficients of x by the constant terms 17, 11, minus 5. Then we write coefficients of y, which are 2, 2, minus 5. Then we write coefficients of z, 3, 1, 1 equals the first element from the first row, 17, multiplied by its minor, which is 2, 1, minus 5, 1, then minus sign, then second element 2, multiplied by its minor, which will be 11, 1, minus 5, 1, plus the third element 3, multiplied by its minor, which will be 11, 2, minus 5, minus 5. It will be 17 multiplied by, it will be 2 plus 5 minus 2 multiplied by 11 plus 5 plus 3 multiplied by minus 55 plus 10, which will be 17 multiplied by 7, which will be 119. 16 multiplied by 2 minus 32 minus 45 multiplied by 3, it will be minus 135, which will be 119 minus 167, which will be 2, which will be minus 48. So we write dx equals minus 48. Now we will evaluate the determinant dy, which will be first coefficients of x, 1, 3, 1. Then we replace the coefficients of y by the constant terms 17, 11, minus 5. Then we write coefficients of z, 3, 1, 1. It will be first element of the first row, 1 multiplied by its minor, which will be 11, 1, minus 5, 1, minus second element 17 multiplied by its minor, which will be 3, 1, 1, 1, plus the third element 3 multiplied by its minor, which will be 3, 11, 1, minus 5. It will be 1 multiplied by 11 plus 5 minus 17 multiplied by 3 minus 1 plus 3 multiplied by minus 15 minus 11, which will be 16 minus 34 plus 3 multiplied by minus 26, which will be 16 minus 34 minus 78, which will be minus 96. So the value of dy will be minus 96. Finally, let us calculate dz, which will be first coefficients of x 1, 3, 1, then coefficients of y 2, 2, minus 5. Then replace coefficients of z by the constant terms 17, 11, minus 5. So the first term 1 multiplied by its minor, which is 2, 11, minus 5, minus 5, then minus sign. Second element 2 multiplied by its minor 3, 11, 1, minus 5, then plus the third element 17 multiplied by its minor 3, 2, 1, minus 5. It will be minus 10 plus 55 minus 2 multiplied by minus 15 minus 11 plus 17 multiplied by minus 15 minus 2. It will be 45 minus 26 multiplied by minus 2 plus 52 minus 15 minus 2 minus 17 multiplied by plus 17 minus 289. It will be 97 minus 289. It will be minus 192. So the value of dz will be minus 192. According to Cramer's rule, the value of x will be dx by d, which is minus 48 by minus 48, which will be 1. So the value of x will be 1. Next, y will be dy by d, which will be minus 96 by minus 48, which will be 2. So the value of y will be 2. Z will be dz by d, which will be minus 192 by minus 48, which is 4. So the value of z will be 4. So x equals 1, y equals 2, and z equals 4 will be the solution of these three linear equations in three variables x, y, and z. Friends, if you like this video, please click the like button. Share this video with your friends and classmates. Do subscribe this channel to get more videos of this type. See you in the next video. Until then, keep watching Number Collage. Thank you.